Okay, hello scholars. Today in our laboratory, special laboratory Monday, we have a lab on density, the density of matter. And as we're learning, density is a property of particular matter. Every kind of matter has its own density. Density, we've learned, is mass and volume. You need that information on the material, then we can determine its density. All materials have their unique density. You have a density, I have a density, this aluminum block has a density, this wood block has a density, these various shapes of copper have density. And today in the lab, we're making use of a triple beam balance, a graduated cylinder, and a ruler to determine the density of various objects. And I have my data sheet here. I'm going to share my data with you so you could do the calculations and answer some questions and do some wondering about this quantity of density. So I'm going to show you a little bit of how these data are collected, then you'll get the data to analyze and make use of to answer some questions. This is aluminum block from which I've got the dimensions, length, width, and height. In fact, they're all quite similar. It's almost a perfect cube, and I wrote those down. And I'm going to share those with you. It was 3.10, 3.00, and 3.05 centimeters length, width, and height. Then I put it on this triple beam balance, waited for it to equilibrate, and I moved our little slide weights here till it was exactly at the mark, and wrote down 84.60 grams. Okay, so now for this block we have length, width, and height, and we have the mass. So with those measurements we can determine the volume, and we have the mass. So there is, we have mass and volume. We could calculate the density of this. Now I did the same, and you'll get the data for this wood block and for this iron block. And very much different in weights than these three. So you'll calculate the density of those with the data. Now we also have these it's called irregular objects. This is aluminum pellets. Now what we're going to do, we have to do something slightly different. First we're going to get the mass of the aluminum pellets, which we do in the same manner. And just do that. Okay, and just gotta get that. It's 20. Okay, I read it and write it down as accurately as possible. Is here 20.02 grams. Okay, so now can't possibly measure these. These are not an object that you can measure and get the volume. So what we're going to do is I'm going to put them back here, have the mass of this, and I'm going to make use of the graduated cylinder. And so at about halfway, I have 60.00 milliliters on this. And now I'm going to put this, I wrote that down. want to put these in here, that exact weight that I recorded. Now I'm going to get the new volume of this by holding it in level, and it is 67.8. What I see, 67.8 milliliters. Okay, so now I have two volumes. Now, the volume of these pellets that I just put in here is the difference between the initial volume at 60.00 and the new volume. Right? So the pellets displace the water, and the difference is the volume of these. Right? Pretty ingenious. There's a guy named Archimedes in Greece, ancient Greece, who figured that out, that a material displaced will displace its volume when submerged in a liquid. So pretty cool. And how did he come up with that? He noticed when he got into the bath that the water rose. But he thought, is that volume, that difference in when it rose, is that my volume? Is that Archimedes' volume? And he tested it, and it turned out to be the truth. Okay, so Archimedes came up with that. You might have heard of Archimedes' principle, because he went on to figure out that a material is going to be buoyant. Right? This wood block is going to be buoyant, or it's going to float in water because it's got a lighter density than the water. Right? So the water is pushing up and makes it float. Archimedes' principle. Okay, so we just determined the volume of these pellets of aluminum. Before that, we measured the mass of those. So we have mass and volume of this. Now we can calculate the density. Okay, so I recorded those data. I also recorded, which I did already, I did this similar procedure for the copper and for these cool glass marbles, okay, to get the density of those. I weighed some of them, put them into water, look for the displacement. I did the same for copper, and this really, really heavy stuff, and this is lead, PB, lead. Okay, really interesting materials. These are naturally occurring elements, metals, that we just made mass measurements on this triple beam balance. Some of them, if they're regular, we used a ruler and measured in centimeters, as accurate as possible. And then we also used volume displacement for irregular objects. Okay, so we have enough data to figure out the density of all these materials: aluminum, iron, glass, marbles, lead pieces, copper pieces, and wood. So you have a lot of things that you can calculate. Then we'll compare them to known values and see how close this experimental procedure is to the known values that we could find in a textbook. Right? Then we'll think about, what does this density mean? How could we use this to understand more about the world around us? How could we use this for analyzing maybe an unknown substance? So we'll be thinking a little more about density, and what does that mean as a property of matter.